Have you ever stared at a kitchen faucet and wondered why the water flows the way it does? It's not just water running down. It's a whole world of motion, pressure, and physics in motion. That seemingly simple stream is actually a complex dance of fluid dynamics, shaped by gravity, pressure, and the design of the faucet itself. It's like a tiny river in your kitchen. What you see is the result of countless forces working together, from the water pressure in your home to the shape of the spout and the angle at which the water exits. This isn't just about water. It's about how we interact with everyday objects and how the science behind them can be both simple and stunning. In this video, we're diving into the science of faucet flow dynamics, because even the most ordinary things can hold incredible secrets. So, what exactly are we talking about? When we say faucet flow dynamics, we're really looking at how water moves from the tap to the sink. It's not just about turning the handle, it's about how that water behaves as it flows. This flow isn't just random. It's influenced by gravity, pressure, and the design of the faucet itself. Each movement of water is a result of forces acting in specific ways. What we're really observing is the interplay between different physical principles, like pressure differences, velocity, and even turbulence. These forces shape how the water moves. Understanding these dynamics helps us appreciate the engineering behind something that seems so simple. It's a dance of physics and design. So, in this video, we're diving into the science of that familiar, everyday flow. Because even something as common as a kitchen sink has a lot going on beneath the surface. You might not think about your sink faucet, but it's part of a complex water system that affects your home's pressure and efficiency. Every tap you turn on is a small act with big consequences. If your faucet is leaking or clogged, it could signal bigger issues like pipe damage or poor water quality. Your sink isn't just a place to wash dishes. It's a gateway to your home's plumbing. Understanding faucet dynamics can help you spot early signs of wear and save money on repairs. It's like checking your car's oil. Prevention is better than a breakdown. By paying attention to your faucet, you're not just maintaining a fixture, you're safeguarding your home's water system. It's a small detail that matters a lot. Let's rewind to the 1800s, when kitchen sinks were basic, just a hole in a counter with a bucket. No pressure, no flow, just gravity doing the work. The first faucets were simple, with one spout, no control, just water pouring straight down. By the 1880s, things started to change. Brass valves and spindles made their debut, giving users a bit more control over the flow. These early faucets were bulky, but they marked the beginning of a more precise, regulated water delivery system. The 1950s brought about the modern ball valve faucet, which allowed for a full range of flow control by rotating a single handle. This was a huge step forward, making it easier to adjust water flow with precision and comfort. Today, smart faucets with sensors and touchless controls are changing the game again. They use advanced hydraulics and sensors to adjust flow automatically, making the kitchen sink not just functional, but also intuitive and efficient. From gravity-fed buckets to smart sensors, the history of faucet flow is a story of human ingenuity. Every innovation has made the kitchen sink more precise, efficient, and user-friendly, just like the flow of water itself. Imagine your sink is a tiny river, and the water is like a crowd of people. When the tap is on, they all rush down the drain. But sometimes they slow down, like when someone blocks the path. The water moves because of gravity, just like when you drop a toy in a pool. But the way it flows depends on how full the sink is and how hard you turn the tap. When the sink is full, the water can go down fast enough, so it starts to slosh back and forth, like when you're in a boat and the water moves around you. If you turn the tap too fast, the water might splash up and over the edge, like when you're trying to pour water into a glass too quickly. So, the water in your sink is like a crowd of people trying to get to the bottom of a hill, but sometimes they get stuck, or they rush, or they even make a little whirlpool. Let's start by looking at the base of your kitchen sink. Here, the faucet is mounted, usually above a drain and a waste pipe. This setup allows water to flow through the pipes and out of the sink when you open the valve. Underneath the sink, there is a network of pipes that connect to the main water supply. These pipes are hidden behind the wall or under the countertop, but they're crucial for the flow of water into the sink. The faucet itself is connected to these pipes via a valve system. This valve controls the flow of water into the sink and can be turned on or off with a handle or lever. Before the water reaches the sink, it might pass through a water filter or pressure regulator. These components help maintain a steady flow and clean water supply. Once the water is flowing, it travels through the sink's basin and then down the drain. The entire setup is designed for efficient water flow, drainage, and easy cleaning. Once the handle is turned, it moves a small lever inside the faucet. This lever connects to a valve that controls the flow of water. The valve opens, letting water through the pipe into the spout. Inside the faucet, there's a cartridge or a ball that acts as the main control mechanism. When the lever moves, it shifts this cartridge or ball, allowing water to pass through the opening in the spout. The cartridge or ball is made of durable materials that resist wear and tear. It has small holes or channels that guide the water flow, making sure it comes out smoothly and without splashing. As the lever moves further, the opening in the spout gets larger, letting more water flow through. This is how you adjust the water flow from a trickle to a full stream. The mechanism is designed to be efficient and easy to use. Whether you're washing your hands or rinsing dishes, the faucet responds to your touch with precise control over the water flow. Now, let's look at the clever twist that turns the spinning motion into something even more precise. As the water flows down, it creates a small vortex. But it's not just any vortex. It's a very specific one that helps control the flow rate. This twist is engineered to stabilize the flow and prevent turbulence. The shape of the faucet spout, along with the internal geometry of the pipe, ensures the water moves in a consistent, smooth pattern. As the water spins, it creates a force that pushes against the sides of the pipe, helping to direct the flow downward rather than sideways or upward. This twisting motion also helps to remove air bubbles from the water, allowing for a more efficient and continuous flow. It's a small but smart design feature that makes a big difference. So, the clever twist is not just about looks. It's about function, control, and efficiency. It's how the water moves with grace and precision, right into the drain. When you turn on the faucet, you're not just flipping a switch. You're initiating a complex dance of water pressure and motion. The water flows in a spiral, a vortex formed by the shape of the spout and the pull of gravity. This spiral isn't random. It's actually a form of turbulence that allows the water to flow smoothly and efficiently. Turbulence is a type of chaotic flow where the water particles mix and interact in complex ways. The speed at which the water flows is also tied to the pressure in the pipes. High pressure means more force, which can cause the water to shoot out quickly or even create a splashing effect. But it's not just about pressure. It's also about the size of the opening. A smaller hole creates more resistance, which can slow the flow and increase the turbulence. Understanding these dynamics helps us appreciate how something as simple as a kitchen sink can be a playground for physics, where pressure, flow, and turbulence all come together in perfect harmony. Imagine your kitchen faucet is like a tiny water park slide. When you open the tap, water rushes down the slide, just like it flows out of the faucet. The more you open the tap, the more water flows, just like how more people can slide down a busy water park slide. If you close the tap, the flow stops, just like the water park slide would empty out and slow to a stop. And just like the slide, the water can splash or flow smoothly, depending on how fast it's going and how it's shaped. So in the end, your kitchen faucet is just a tiny water slide, and the flow is all about how the water moves through it. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.